Okay, Oral 6, Traverse City, Michigan. This is a mission 3B flight experiment that is already flown.
Hi, I'm Ashley Miller.
I'm Paxton Elo.
I'm Haley Dole.
And our experiment was testing antibiotics and bacteria in a microgravity environment. Next slide. Our essential question was how bacteria and growth and antibiotics work together in a microgravity environment. We're testing depending on how bacteria infections can be treated in a microgravity environment. And we believe that bacteria growth is higher in space because it can move around a lot easier without gravity, and that antibiotics too would work similar in a microgravity environment. Next slide.
Our experiment design is in section A, which would be on the left side. Inside that chamber, we enclose staph epidermis in a powdered form that would be ready to react with the growth serum. The growth serum is in section B, which we placed because it will be able to mix with the bacteria during the experimental process. In section C, it contained the antibiotics, which was then mixed with our staph epidermis. Next slide, please. 5 days prior to coming back from the ISS, a clamp was removed from our test tube that allowed the bacteria and the growth serum to mix. The bacteria then grew for 3 days aboard the ISS. 2 days prior to returning, the last clamp was removed, exposing the antibiotic to the growing bacteria. While the astronauts performed these tasks, we did the same for the control experiment.
Okay, so when it came back, we did some spectrophotometry tests, and we noticed right away that one of them transmitted more than the other, which was the microgravity experiment. And if you go to the next slide, you can see why, because one is more dense than the other. It had a lot more substance in it. And so those are the pictures of our microgravity and our control experiment when they came back. Next slide, please. In conclusion, we sent it to a lab, and no viable Staphylococcus epidermis was recorded. So our antibiotic managed to effectively kill all of the bacteria in space. But we don't exactly know why the transmittance in the spectrometer was different, but we can guess that it was the bacteria because they started out with the same amount of growth serum and the same amount of antibiotic. So we think that the control experiment on Earth grew more bacteria than that of the microgravity experiment because it absorbed more light in the spectrometer. And we think this is because in space, there was a lot more room for the bacteria, and as soon as the antibiotic was released, it could immediately have more contact with the bacteria, able to kill it faster. And the control experiment, it had less surface area exposed, so it might have been able to keep growing for a little bit longer than that of the space experiment. And so that's our experiment. Next slide, please. And these are our collaborators and community partners that helped make this possible.
Thank you.
Questions for Traverse City?
I'm Mary from Rochester, New York, and I just wanted to know, how did you decide which antibiotic and bacteria combination to choose for your experiment?
We chose Staphylococcus epidermis because it's a very common skin infection, and it's very easy to get a hold of.
Any other questions? Let's thank Traverse City, Michigan.